Hey everyone, and welcome to Dr. Abu Artin Academy channel. Today we are going to discuss part 9 of the sets and the probability and the biostatistics subjects, okay? And it will be about Bayes' theorem. Bayes' theorem, as explained here in this slides, it is not so clear, but I have got one example from the internet, from the YouTube, and I'm going to paste it here and explain to you so better you understand and digest it first, then we can read the slides which are given by the university. If you remember in the previous video, we have talked about the conditional probability, and we said that, okay, if I have the probability of A given B will be equals the probability of A intersect B divided the probability of the last one, which is B, okay, which is this one, okay. So this is the probability which we have taken the previous slide. Just let me write it down here. To the probability of A given B equals the probability of A intersect B divided the probability of the last one, which is B. In the same way, I can write the probability of B given A. We have already said that the probability, conditional probability, in it, the order matters. So the order matters, and we can reverse them in the given probability. It's very important. So probability of A given B, it is not the probability of B given A. So it will be equal to probability of, or let us use the different color, probability of B intersect A divided probability of the last one, which is A. We have already mentioned also that the probability of B intersect A or A intersect B, both are the same. So I can write in different way. I can write probability A intersect B, okay, equal divided probability A. It is the same thing. Nothing changed. This one and this one are the same, okay. So, okay, I can do substitution of this probability of A intersect B. Okay, so probability of A intersect B from this formula, okay, will be equal probability of B given A, this one, multiplied by this one, cross multiplication, okay, probability of B given A, this one, times BA, probability of A. So I can use this one, the probability of A intersect B equals probability of B given A times probability of A, and substitute it here in this formula, okay. If I'm explaining to you in this example, so better here, okay. So here I have the probability of A given B equal the probability of A intersect B divided the probability of B, which is the last one. The probability of B given A equal the probability of B intersect A divided probability of the last one, which is probability of A. So I can use this one, okay. I can just write it here, probability of A given B, and I'll replace this probability of A intersect B by this one. Probability A intersect B equals probability of B given A times probability of A, which is this one, probability of B given A times probability of A, okay. So here the probability of A given B, I just wrote it down. The probability of B, I just wrote it down. The only thing, I have replaced the probability of A intersect B by this one. Okay? Okay, so it will be probability of B given A times the probability of A. So again, the last part to make sure that is understood, okay? So I have the probability of A intersect B, this one, equals the probability of B intersect A, because both are the same, just it doesn't matter, A intersect B or B intersect A, it doesn't matter. So if I use the last one, probability of B intersect A, it will be the probability of B given A times the last one. Okay, this one I've taken the last video, okay? So I can replace the probability of B intersect A by this one in the formula. So I can replace this one by this one. So I end up with the probability of B intersect A times probability of B given A, probability of B given A times the probability of A divided the same thing here. So here, this one remains the same. Probability B of B remains the same. The question itself, probability of A given B remains the same. The only thing which we have changed, we have replaced this one, probability of A intersect B, by this one. Okay? So what is the benefit of doing all this exercise and going around around the conditional probability and doing all this way? What we want to arrive or reach to? Actually, what we are trying to arrive here or to deliver here is that we want to create a relation between probability of A given B and B given A. So the other way around, because in some problems we are requested to get probability of A given B, but we don't have the probability, the other probability. We have the probability of the other with the opposite, the other way around. We have the probability of B given A, or the probability of given A, probability of A given B is required, and we have the probability of B given A. Okay, so we need to switch between them. If we have one of them, we need to understand how to get the other one. So now, by having this substitution, which we just have, we arrive to this formula that the probability of A given B equal, we can reverse it, the probability of B given A. So the same thing, just I swap them, A and B. Okay, just concentrate with me 1 minute, and you will fully digest it and you will memorize it as well. So the probability of A given B equals the probability of B given A times the probability of the first one, and divided the probability of the last one. Always that we divide by the probability of the last one. Okay, so again, the probability of A given B equals the probability of B given A. I swap them, okay, times the probability of the first one, probability of A, divided the probability of the last one, probability of B. This is called Bayes' theorem. So it helps us a lot. Actually, it helps us a lot if we have the given, which is the opposite, or we swap the given. Okay, so it helps us a lot in such cases. In the same way, I can have the probability of B given A. The same way, equals the probability of A given B times the probability of the first one, which is B, divided the probability of the last one, A. In some books, and also this is the case which we have here in Debrecen University, you remember that we got the probability of A for this conditional probability. The probability of A in the last video, this was the probability of A equals the sum of A BI, okay, or the sum of the probability A given BI, the probability A BI, the probability of A given BI times the probability of the last one BI. Okay, sometimes using this substitution in the denominator, instead of writing probability A, they are writing the probability, the sum of the probability A given BI times probability of BI. So, in order also to help us to fully digest and understand this Bayes theorem, I have got an example from the YouTube, from the internet, and I pasted here for you so we can review on it. So what is the probability? We have two ladies, okay, and I have a couple, man and his wife, okay, and they have got two girls, okay. So what is the probability of getting two girls? I have a couple, the man and his wife, and they have got two kids, two children, okay. One of them is given that she's a girl. So what is the probability of having them, both of them are two girls, given that at least one of them is girl? So we are sure that at least one of them is girl, but maybe both of them will be girls, okay. So the question, what is the probability of having them as two girls, given that at least we know that one of them is girl? Coming back to the probability, so what are the possible scenarios that we have? The first one girl and second one boy, or the first one girl and second one girl, okay, or the first one boy, second one girl, the first one boy and second one boy, okay. So these are the possible probabilities, okay. Okay, so what is the question? How we can formulate it in the form of conditional formatting? He's asking what is the probability of two girls. So his question, the probability of two girls, giving at least that one girl. So given, okay, one girl, I have one girl. So he wants the probability of two girls given that's one girl. So if we used the formula which just we saw now, so this is the formula which we just derived now. The probability of B given A was, I can swap them, the probability of A given B times the probability of the first one, probability of B, divided the probability of the second one. So here, can I swap this probability problem? I need the probability of two girls given that I have one girl already given to me. Okay, let us try. So can I swap this in the same way? So I swap A and B, okay? So it will be probability of A given B instead of B given A. It will be probability of A given B, then times the probability of B divided the probability of A, or the last one will be in the denominator down, okay? So the same thing I'm going to use here. The probability of 2G given 1G, one girl, will be equals the probability of 1G, I swap them, 1G, okay, given 2G. Then I have to multiply by the first one, not after swapping, before swapping, times the probability of 2G, okay, divided the probability of the last one, probability of 1G, okay, which is this form. If you look at this one, it is the same as this one, okay. The probability of 1G given that we have 2G times the probability of 2G, okay, which we are having here, okay, divided the probability of 1G, okay. So now, what is the probability of 1G girl given that I have 2 girls? If someone told you that you have 2 girls, what is the probability of one of them being a girl? Already there are 2 girls. You already got 2 girls. So here the probability of having 1 girl, given that both of them are girls, so it is 100%. It is 100%, right? Because they are already both are girls. So probability that one of them is girl is 100%. So it will be equals, this one will be 100%, which is 1 times the probability of 2 girls. What is the probability I have 2 girls? So if I check here the distribution which we have, if you remember, here the probability I have only 1 chance of having 2 girls. This is the normal distribution. Girl and boy, girl and girl, boy and girl, boy and boy. So only there's 1 chance of having girl and girl. So 1 out of how many? 1 out of 4. 1, 2, 3, 4. So 1/4, which equals to 0.25. So times 0.25. Okay? Divided the probability of having 1 girl. So in this case, I have here 1 girl. I have here at least 1 girl. I have here at least 1 girl. Okay? So here there is 1 girl. Here there is 1 girl. Here there is 1 girl. Here I have 2, but at least I have 1. So 1 girl is applicable also here because I have at least 1 girl. I have here 1 girl. I have here 1 girl. So 3/4, okay, which is 0.75. Then I just multiply them and I get the answer, which will be after simplifying 1/3. Okay, and if you remember initially from here, if we want to check the probability that the probability of 2 girls given at least that I have 1 girl, from this logical way we can easily arrive that it is 1/3. Okay, so to be frank with you, I always prefer to use this formula rather than the one which is in the slides of the university, because this one is very simple and it's easy to memorize. So here it's very easy to know that the probability of B given A, I can just swap them, A and B, make it probability A given B, okay, times the first one, probability of first one, divide the probability of the second one, and that's it. Now we'll see what has been written in the slides of Debrecen University. So here in this slide, Bayes' theorem can be used to calculate a conditional probability in the knowledge of reverse conditional probability. So if I know the probability of A given B, I can use it to calculate the probability of B given A. This is the purpose of having this Bayes' theorem, and actually it is very helpful, okay? So it can be used to calculate the conditional probability of A given B if I know the probability of the reverse, which is B given A, or the other way around, okay? And the marginal probability as well. The marginal probability, which is probability A or probability B. If you remember, this is the one. Okay, we have here, see, at the denominator. So here I have the probability B given A. I use the probability of A given B to get the answer of probability B get A. But I should have also with me the marginal, okay? The marginal probability of probability of A, okay? Which we have taken in the last slide, that it is the sum of A given B times probability of B only, okay? The sum of them, B1, B2, B3, and so on, okay? This one is more simpler, as I said, as I mentioned earlier, that this one is more simpler, but also we'll come in touch with the one which mentioned in the slides here. So, Bayes' theorem can be used to calculate a conditional probability in the knowledge of reverse conventional probability, okay? Knowledge of reverse conventional probability, and marginal probability, which is probability of A or probability of B, the one which is in the denominator. For example, knowing the probability of A given B, conditional probability, Okay, and always we take the probability of the last one. So probability of B, we have to take the marginal probability of B. Okay, like here, see, we have A, probability of B given A, we'll find in the denominator the probability of A. So the last one always in the denominator. So I have to know the reverse one, which is this one, and the one which is in the denominator, because I have to substitute here and substitute here. Okay, for example, knowing the probability of A given B conditional probability and the marginal probability BI, which is the last one, marginal probability, the probability of B given A, forget about K, probability of, because we have I and we have K, that's why they put K, the probability of B given A, reverse conditional probability can be calculated. So I have A given B, here you want to get B given A, okay, B given A. So probability of B given A equals the probability of A given B, because this is the purpose of all this exercise, that I want to swap them to get the reverse one, okay, to use the reverse one to get the answer of this one. So I need the probability of B given A. Okay, I can use the probability of A given B times the probability of the first one divided the probability of the last one, which is probability of A. Probability of A, if you remember in this slide, we have taken it, probability of A will be equaling the probability of A BI, A intersect BI, okay, the sum of them, the probability of A, this A intersect with B1, probability of intersect with B2, AB3, AB4, and so on. So this is the probability of A. It is the sum of these probabilities, okay? The sum of probability of A given B1, probability of A given B2, probability of A given B3, and each one of them times the probability of BI, okay? So here you can memorize BA or you can use this one. But if you use BA, you have to be knowing the marginal probability as well, okay? If you memorize the marginal, you can get BA separately and just substitute here, okay? No need to memorize all this big formula. Okay, the Bayes theorem can be used to answer the following questions, okay? In the above example, if an affected person is selected from a population, what is the probability that the person is a man? Or what is the fraction of the men among the affected people? So this is the same example which we have taken in the previous slides, this one, with the same percentage. So here the question is, what is the probability that the person is a man? So he wants the probability of man. What's man? Man was B2 in our example and woman was B1. So probability of B2, okay, given that he is affected, he's among the affected, that the people are affected. So given A. So probability of B2 given A. I can write it in the other way around, okay? So I can say here, okay, the probability of B2 given A equals the probability of A given B2 and times the probability of the first one, which is B2, I'm just adding 2, and probability of A. So what is the probability of A given B2? Okay, the probability of A that he's affected and given that he's B2 the man. So the probability of a man who's affected was 0.06. So I can write it here 0.06. Actually he put it here. This one should be first and 47 should be the second. But anyway, it doesn't matter. The probability of A given he's a man is affected, the probability that he's affected and given that he's a man is 0.06. This was in the previous example here. if we erase this one, okay, the probability here was 6% for the man, he's affected. Okay, so we'll use the same percentage. So here 0.6. So what is the probability of being B2? B2 is the man. Probability of being a man, we said that the man is 47% in the previous example. Divided the probability of probability BA. Okay, PA, we can take it from the previous example, or we can calculate it from here. Okay, the probability, or we can calculate it separately and put it here, the probability of A BI, which is A B1, A B2, and so on. We have already calculated this in the previous example. Okay, so it will be 0.53 times 4%. Okay, AP1 plus AB2 will be 0.06 times P2, which is 0.47. And if we are done with this calculation, we'll end up with the result, which is 0.571, which is 57.1. And this is the probability that he's a man and he's affected. As given in the example, is asking the probability of being a man, the person is a man and he is affected. Okay, I hope this is clear, and we will come in the next video with some of the examples.